Let's take a look at this example that involves a piecewise function. Find the integral from -1 to 4 of f of x dx, where f of x equals e to the x if -1 is less than or equal to x is less than or equal to 0, 5 if x equals 2, and x plus 2 if 0 is less than x is less than or equal to 4 for x not equal to 2. Let's take a look at a graph of this. Y equals e to the x is this exponential function, but we only want the piece of it between -1 and 0. So notice it's just that piece. Y equals 5, but only at x equals 2, is the point 2, 5, which we see right there. And then we have y equals x plus 2, which is linear, this line, but only between 0 and 4, and not when x is 2. So hence this line that goes from x being 0 to x being 4, but has a hole where x is 2 because there's another point in a different place at x equals 2. Either way, we're trying to find the definite integral from -1 to 4. But it's broken up, that interval, with different functions. So we have to break up that integral. That integral from -1 to 4 of f of x dx will need to be written as separately as -1 to 0, because that's the first interval right there, -1 to 0, for the function e to the x dx, plus, now we pick up where we left off at x equals 0, which is this interval right here from 0 to 4. But notice that it's not including 2. So we have to break this up into two integrals, 0 to 2 of f of x dx, plus the integral from 2 to 4 of f of x dx. Oh, I realize I could have plugged in that x plus 2 into that spot. Instead of f of x, x plus 2, x plus 2. Now it's like 3 problems in one, where we'll add together all the answers at the end. Let's go ahead and take the antiderivative using our fundamental theorem of calculus. The antiderivative of e to the x is e to the x. That's an easy one. Put my brackets because I remember I still will have to evaluate the antiderivative at those limits, plus the antiderivative of x plus 2, 1/2 x squared plus 2x, and that's from 0 to 2, plus, and then again, because it's the same function, 1/2 x squared plus 2x, but this time from 2 to 4. Let's go ahead and plug in our values. Upper limit first, e to the 0 minus lower limit, e to the -1, plus 2 gets plugged in, so that'll be 1/2 2 squared plus 2 times 2. And 0 plugged in is going to make everything in here 0. Well, that's a nice one. Plus, second one here, plug in the 4. 1/2 4 squared plus 2 times 4. And this time my lower limit is a value that won't make everything disappear. So let's put big parentheses and say minus 1/2 2 squared plus 2 times 2. And then we can do some simplifying. E to the 0, of course, is 1 minus e to the -1 can be written as 1 over e, plus this over here is going to make 4 divided by 2 is 2, plus 4 is 6, plus 8 plus 8 there is 16. Evaluate this, minus 6. I do have an answer. Actually, from this line, I have an answer, but I'm going to go ahead and clean it up because I can. So the 6's make 0, and that looks like I've got 17 minus 1 over e. So the point of this one, if I have a piecewise function, just look carefully at the domain restrictions. You might have to split up the interval into separate integrals.